So it is expected that it is already started. Yeah, so now it is started.
Yes.
Okay. So let's continue where we left the question. So I think till question 5 we have done, because for question number 5, so for this question you have given me a counter example so that you can disprove this statement. All right, everybody is with me on this statement. Hello.
Yes, sir.
Yes, so for question number 5, so last question which we have discussed, that is the question number 5. Okay, and for this question, so few students given a counter example so that you can disprove this statement. Okay, can you just recall that what was that example, so that we can just come up to quickly to the question number 6.
Sir, V equal to
Yes,
R
ma'am.
to the power Q over R, and U equal to
Okay,
R.
let me write that V equal to, yes,
RQ over R, and U equal to also R square over R.
so you are saying V equal to R cube over R,
Yes, sir, R
is
cube
it?
over R.
And now
सर
what you
एक
are
सब
saying,
स्पेस
U,
था.
And U equal to also R cube over R.
yes.
And W1 equal to
Mhm.
W1 equal to order pair X, 0, such that X belongs to R.
Okay.
And W2 equal to order pair 0, Y0, Y belongs to R.
0 y 0 y belongs to R.
So here clearly
Okay.
U plus W1 equal to RQ over R, and U plus W2 equal to RQ over R, but W1 is not equal to W2.
Okay. Yeah, this is fine. So can you give me an example, okay, where the U is not the trivial subspace of V? So here that U is exactly V, right? This is what you have taken.
Yes, sir.
You may have some other examples also, right?
U is
Like
equals
over
to
R.
Yes sir, अगर W को
So
मैट्रिक्स स्पेस में कर सकते हैं इसे. W is the vector subspace of upper triangular matrix, and U is the vector space of all matrix M cross N, or W is the subspace of lower triangular matrix.
what is your V? Can you repeat?
V is the vector space of all matrix M cross N.
And what is U?
U is equals to V.
No. So what I was saying, that is fine. This example is okay. So I just, I mean, want an example where this V is not equal to U. I mean, this U is a proper subspace of V, because U is the subspace of V.
Sir U को V के इक्वल ले सकते हैं ना.
Yes,
U
yes,
is the
you can
vector
take.
space.
Okay, fine. You can take. I mean, this example is fine. What I was just asking, that you can also construct an example where this U can be a proper subspace, not just this. I mean, not just that exactly the same as V. That is this example is also fine, and nothing is wrong in this example. Okay.
Sir, in the same example, we can consider U equal to 0, YZ for Y and Z belongings to R. So that will be also same.
So what you are saying?
No, sir.
That will not be same. We can consider U is
No,
equals to
sir.
X comma Y, X comma Y, X comma Y comma 0.
Hmm.
Yes, sir.
X comma Y
Mm-hmm.
to R.
Yeah. Yes. So why just I am asking you that, okay, because you can construct this way also. This is not always the case that you have to take this u equal to v. I mean, you can construct some more example like this. Here you have told me that you can take this u equal to xy0, where xy belongs to the real numbers, and this you can you may check that this u is also the subspace of this vector space, this R3 over R, and this W1 plus U equal to W2 plus U. You can also verify that this over normal sum, this is W1 plus U equal to W2 plus U. But here you can easily see that these two are not same. W1 is not equal to W2. So we have the counter example here, so that we can disprove this statement. Now move to the next, the immediate question, that is prove or disprove for everything is same here. W1, W2 and U are the subspaces of V, such that, but here the only difference you can see. What is the difference? First you tell me what is the difference between the question 5 and 6.
In case of there is
सर इसमें
direct
डायरेक्ट सम आ गया.
Intersection is 0. Of
Tell
W
me one by one.
to U. Intersection is only
Is a
0 element.
what is the difference? Can you again? I haven't heard you.
W1 intersection U
Hmm.
is equals to only 0 element, and W2 intersection U is 0 element.
और इनका लीनियर सम वेक्टर स्पेस के इक्वल होना चाहिए.
Yes.
Okay, so
Sir,
you are
जरूरी
telling
नहीं
me
है.
the.
ऐसा कुछ जरूरी नहीं है.
नहीं, डायरेक्ट सम के लिए तो v इक्वल टू लीनियर सम इक्वल होना चाहिए ना, फिर इंटरसेक्शन 0 वेक्टर के इक्वल होगा. तभी तो डायरेक्ट सम बोल रहे हैं उसे.
So first of all, I was asking that what is the difference. So you have to tell me. Okay, there in that first question, that was the just normal sum, and that was taken. That was just sum. But here we have direct sum. Now you are whatever you are telling me, that is the meaning of the what do you mean by direct sum? Okay. So for W1 plus U, I mean for W1 plus U, I mean here that every vector is of this form. For this whole space, every vector, I mean, so it must satisfy this W1 plus U. If we say that this V belongs to W1 plus U, then this V has of this form, like let's say W1 plus U1, and where this W1 is coming from this W1, and U1 is coming from this U, and this W1 intersection U is this. Okay, this is the extra thing that you have to consider. Now, okay, so that is the difference here. Here in the previous question, that was the normal sum. Here you have to consider that it is a direct sum. Now tell me whether you can prove or disprove.
so direct sum is the
disprove.
smallest subset
Sir,
which
disprove.
contain V.
डिस्प्रूव करेंगे सर इसको.
Have you done that?
Yes, sir.
Yes sir.
Yes, sir.
Okay. So let us, I mean, listen. Those who are try to disprove that. Okay. So how you have done? Just tell.
Sir, V be the vector
Everybody.
space R2 over R. Let U be the vector subspace X, tuple
So
X,
you are
comma
disproving,
X.
right?
Yes, sir.
You are
By
disproving,
counter
right?
example.
Okay.
Yes, sir.
What is that counter example? Just yeah. What is V or
R2 over R, sir. V.
R2 over R? Okay.
Yes.
And
U is equals to X tuple, where X belongs to R.
where X belongs to R. Okay.
W1 equals to X,
W1
comma 0.
X comma 0, where
X
X
belongs
belongs to R. Okay.
W2 0, comma Y, where Y belongs to R.
0 comma. Okay. You can also take X, na? That is
Yes.
nothing any problem. So
So, sir, it form direct sum W1 plus U and direct sum is equals to V, and W2 plus U direct sum is equals to V, but they doesn't equal, sir, W1 and W2.
Is it whatever she is saying is it correct?
No,
Sir,
sir.
I have a
I
doubt.
think
No,
So here direct
No,
sum
sir.
is not equals to B.
not equals to
Because
zero.
okay, let's come to stick to this example and we will listen. Just wait a minute. So why it is not correct? Because this is u plus, if you take this u plus w1, okay, if you consider this direct sum u plus w1, then this u intersection with w1, that must contain only zero vector intersection with this. Is the intersection of this u and w1 is only the zero vector? First answer to this question.
No, sir, it will be W1.
No, sir. It
है ना?
will be
Okay,
W1.
so it will be w1, it is not zero. So if you are try to disprove this statement, first you have to satisfy, first you have to take such subspaces that will satisfy the definition of
सर U intersection W1
that
equal to
example.
zero.
Not
Sir, zero.
जीरो वेक्टर ही होगा सर,
तो
क्योंकि
zero ही तो
U
है,
में
तो
X
zero है।
Yes, sir.
so you are saying u intersection w1 is a zero vector here?
Yes,
Yes,
sir.
यस
sir.
सर,
No,
क्योंकि
sir.
सेम है ना, क्योंकि U में एलिमेंट
If we
X
U
और
take
में
Z के है ना.
access
sir,
सब पता है।
zero.
Okay, just a zero.
Yes, sir. Yes, sir. It intersection is zero only.
The problem is that W1 direct sum U is not equal to W2 direct sum.
Hello,
सर इसमें
यस सर.
your voice is broken. Yeah.
सर एक्चुअली सर आई थिंक सर जब इसको डायरेक्ट सम में ऐड करेंगे तो सर लेफ्ट साइड जाएगा 2 टाइम्स ऑफ x कॉमा x आएगा, और राइट साइड जो आएगा सर वो x कॉमा 2 टाइम्स x आएगा। तो सर टपल वाइज वो इक्वल नहीं हो पाएंगे शायद इसमें।
Sure, the direct
Yeah,
sum
so
is
this
also
condition, actually this condition is not satisfying with the
no,
direct
sir.
sum, no?
Sir, every vector of
If
V can
w
be represented as U plus V, sir.
Yes, sir, it
यस
can
सर,
be
इसमें
represented.
W1 प्लस ये
okay,
दोनों इक्वल नहीं
so
होंगे सर,
wait a minute.
W1
So
W2 के लिए.
this condition will not satisfy. Those who are with me, that is fine. Those who are not with me, like w1 plus u, with this example, w1 plus u is not equal to w2 plus u. That's what I was saying.
यस सर,
Okay,
Yes,
यस
sir.
सर।
everybody is with me on this, because so if you if you take let's say if you take, let's say v here, v belongs to this, the left hand side of this expression. So v would be of the form v, let's, okay, so, v would be of the form w1 plus, okay, w1 plus u, and this is of the form, w1 is of this form, right? This is, and this is of the form x comma x, and what would it be? This is 2x and x, okay. And if you take any element, if you take here any element here, let's say you, let's say w, so let's say w belongs to w2 plus u, then w is of the form w2 plus u, where w2 belongs to, small w2 belongs to w2 and u belongs to u, and because it w2 is of the form 0 x, of course this x is any real number, so here you may choose some, let's say y, plus this is of the form y y. So this is y into y. Okay. So if you take, let's say, the real, if you want to say this is equal to this, then you have chosen this
Excuse
v
me,
as a
sir.
general. Mhm.
Sir, but any vector of v can be expressed as u plus w1. See, let's take a general vector x comma y. Please write, sir.
Say it again.
Let x comma y be a vector of v, so it can be represented as y comma y order pair plus x minus y comma 0.
Just a minute. So whatever you are saying, just I'm writing x comma y is any element of v. Okay.
Yes, sir.
So you can
Is
write,
equal to
yes, is equal to
y comma y
y. Okay.
y comma y
Mm-hmm.
plus
Mm-hmm.
x minus y comma 0.
X minus y comma 0.
So y comma y is from u and x minus y comma
Hmm.
0 is from w1.
No. So that is fine. That is fine. There is no problem in the. I mean, I am not saying that this cannot be represented in this way. What I was just saying is that for the choice of w1, w2, and u, this condition is not hold. I mean, this w1 plus u is equal to w2 plus u. That is not
सर
satisfied
W1
here.
Sir,
plus
it is correct,
W2
sir.
शो करते हैं
It
सर.
is correct. No,
Sir, it is
correct.
correct.
Sir. Similarly, we can write for W2 and U.
सर जब हम W1 और U के एलिमेंट्स को ऐड करेंगे तो 2x, x डबल नहीं
Yeah,
बनेगा कि हम आर्बिट्री एलिमेंट्स को ऐड कर रहे हैं ना, तो 2x ही थोड़ी आएगा वहाँ पर, जरूरी थोड़ी है.
So what is the confusion here? So you are saying w1 plus u.
सर जो अगला सर जो ये तो W1 के लिए था, मान लिया यही रिप्रेजेंट कर दिया y कोमा y प्लस एक्स माइनस वाई 0, लेकिन जब सेकंड के लिए करेंगे तो फिर वो x माइनस वाई फिर नीचे ले जाना पड़ेगा हमें, y माइनस x,
हाँ,
इधर x कोमा x प्लस, वो भी डिफरेंस हो गया ना फिर यहाँ पे,
नहीं आर स्क्वायर तो आया ना फिर से, क्योंकि हम सेट पे बात कर
ऊपर
रहे हैं.
वाले
क्योंकि W1 के लिए सिर्फ नीचे 0 आ रहा है और उसमें W2 के लिए फिर ऊपर 0 आ जाएगी ना
और
इसमें.
दोनों ही R2 होंगे ना.
है तो
वही
दोनों
दोनों
R2
दोनों R2.
V के बता रहे हैं ना.
सर ऊपर वाले के लिए बेसिस 2,0, 0,1 हो जाएगा और नीचे के लिए 1,0, 0,2. तो सर दोनों डिफरेंट हैं.
ये नहीं
No,
होगा.
so
2 is not compulsory.
एक्स को आर्बिट्री एलिमेंट जैसे कंसीडर करो या इसको सेम मत कंसीडर करो.
यस सर, मतलब
हाँ,
जो
एग्जैक्टली.
Exactly, both are
स्टार्टिंग
different.
में ही फिर डिफरेंट लेके चले हम लोग, क्योंकि वो तो सेम ही लग रहा है ना.
That is representation, how you see.
so what you are saying here?
सर हम बोल रहे हैं कि W1 और U के जो एलिमेंट्स हैं उसमें हमने जो नोटेशंस यूज किए वो हमने दोनों जगह x ही यूज कर लिए, तो जरूरी थोड़ी है कि हम x, 0 के कॉरेस्पॉन्डिंग x, x टपल से ही ऐड करेंगे, वो तो कोई आर्बिट्री टपल हो सकता है ना. तो दोनों की आप नोटेशन चेंज कर दें, क्योंकि ये जो 2x,
Okay.
x टपल आ रहा है वो गलत आ रहा है आंसर.
Just a minute, huh?
सर W1
सर
और W2 का
ज्योमेट्रिकली रिप्रेजेंट
रिप्रेजेंटेशन
करके देख
चेंज कर
लीजिए
दीजिए
तो
प्लीज.
आसान हो जाएगा.
Geometrically is this ना? Geometrically.
सर इसके लिए वो भी था एग्जाम, क्वेश्चन नंबर 5 के लिए जो एग्जांपल दिया था उसके भी कर सकते हैं, क्योंकि अगर डायरेक्ट सम इक्वल है तो उसका लीनियर सम भी इक्वल होगा, इसलिए फिर लीनियर सम इक्वल नहीं है, क्योंकि क्वेश्चन नंबर 5 में हम पहले ही डिस्प्रूव कर चुके हैं ना, तो वाला एग्जांपल यूज कर लेंगे, क्योंकि ये तो बड़ा डिफिकल्ट सा लग रहा है इसे.
So you are saying that we can disprove this?
यस सर, क्योंकि लीनियर सम भी तो इक्वल होना चाहिए ना इनका.
May I interrupt
Yes,
here?
yes. Yes,
So,
sir.
so what
Yes,
is the
yes, sir.
confusion here? So, so this is prove or disprove? First, you tell me. This is prove or disprove?
Disprove
Yes,
है.
this is disprove. So you can disprove it just by giving one example, and the example you are seeing it here, I mean on the screen. That example itself will work,
Yes, sir.
right?
Yes, sir. That we are
So
saying.
then, yeah, so that is true.
Yes.
So I think this example will work, and this is a disproof, so you won't be able to prove it.
Yes, sir. Clear.
Okay, yeah, fine then. There is no confusion.
Yes. Okay. Okay. So that will the same example will work here also. You may change this these notation because so that there will be no confusion. Instead of x, you can take
Yes,
here
sir.
y and z also. Okay, and
Yes, sir.
then we'll move to the next question. So for this question number 7, that is, have you tried this? Because in the last session, I asked you to do it by yourself because it's like the similar exercise.
Yes sir, सर इसके लिए सभी प्रॉपर्टीज का यूज किया है इसमें क्योंकि वेक्टर स्पेस प्रूव करने के लिए.
So you
क्लोजर
just have to write all the 8 properties.
Yes, sir.
4 with respect to addition and 4 with respect to
multiplication.
multiplication.
Yes sir, over the field are.
Okay, so everybody has done that, right?
Yes, sir.
Okay. Yeah, so move to the next part of this sheet. That is, so this question to prove that if v1 to vn this set spans the vector space V, then this the given set also spans the vector space V. Okay, that's what you have to prove. So how you have done that this question?
सर इसके लिए लीनियर कॉम्बिनेशन लिखा है किसी एक वेक्टर स्पेस का फॉर ऑल कोई.
First, okay, so before you going to tell the answer, first you tell me what do you understand by the span? I mean,
सर इसमें ये दिखाया गया है कि v1 to vn के
No.
जितने वेक्टर
so what I was asking,
Sir,
just tell me the definition of a span of set.
span
S-
of set
every
of all
of
linear
vector
combinations.
space.
और finite linear combinations.
all finite linear combination, correct? Where
Vi
Alpha I
belongs
belongs
to
to F.
S and Vi
Alpha.
belongs to S.
Vi to S and this alpha i's are coming from field and n is natural number.
Any natural number.
So
Yes.
this is the definition. Here S is any set containing this v1 to vn, then this we call that span. So okay, so I have to represent it by span of S. Okay, span of S. Now, yes, now you have to show that. I mean, so this is the given thing that v1 to vn spans the vector space V. Now you have to show the given the given set v1 minus v2, v2 minus v3, and vn minus 1 minus vn and vn will span the same vector space. Now, yeah, now you tell.
So for this, we considered C1, C2, Cn, some scalars, and multiply these with V1 minus V2, V2 minus V3, same as respectively, and write this linear combination.
So everybody
Like,
is understood this?
like C1, B1 minus B2 plus C2, V2
So
minus,
okay, so
like
whatever
this.
you are saying, just tell me. What you have taken?
C1, C1, C2, Cn are some scalars from field F.
Okay.
Then we can write C1 multiply V1 minus V2 plus V1 minus V2 in bracket, yes, plus C2 V2 minus V3 and so on, and like C and Vn, dash C and Vn is now simplifying this C1 V1 minus C1 V2 plus C2 V2 and so on.
Then
No, C1 B1 plus C2 B2 minus C1 B2 minus C1 B2 will come.
okay, I got you. Yeah, then okay, just tell me orally. Okay, then you if you just
Then these scalars will, we can write these scalars as like we get C2 minus C1 and C3 minus C2. There we can write the
yeah,
alpha
I got
1, alpha 2,
I
alpha
got
n.
it.
We can write them alpha 1, alpha 2, alpha n.
What is the value of alpha n?
Alpha n equals to alpha Cn. Alpha n equals to Cn, C1 equals to alpha 1,
Okay,
and
so
rest.
okay, uh, yeah, whatever you're saying, that is, I mean, so we will see that is it making sense or not. Another any other try?
Yes, sir. Same procedure लग रहा था ये.
Okay, so let's see how we can do it. Let's start with. So the given thing is that this V1 to Vn spans a vector space V. So we can write, I mean, if we here hello.
May I?
Yes.
It is enough to show that the span of this set V1 minus V2, V2 minus V3, and up to Vn contained in the span of V1, V2, Vn, then it is okay. तो अगर हम इसके स्पान को इसके अंदर शो कर देंगे तो अपना हमारा काम हो जाएगा. So first we consider the linear combination of these all vectors. Okay, then simplify. So firstly,
yeah.
Firstly,
That's
C1 V1.
exactly what we are trying to I mean prove. I mean the whatever the previous person is also telling, that is exactly the same thing that you can show the span of this V1 V2 Vn is contained in this given set. Yeah. So let us see, I mean, how we can do. So whatever the given here is that, okay, let V be any element of the vector space V. So you can write this V as so basically there exists scalar V1, let's say Bn belongs to field such that you can represent this V vector as this. Okay. All right. Now, because it is given that the set V1 to Vn spans the vector space. Now you can write, because okay, so this is let's say one thing. Now see, let's say these are the scalars a1 because you have to show so you just be with me. This is like how you exactly get the idea. So basically you want to, I mean, you start with here, consider this thing, and you have to find the values of this a1 a2 a1 a2 and an minus, I mean, up to an in terms of this b1 to bn. Okay, that's that you want to do. So if you just write this, now if you arrange all these, I mean if you just collect all the terms with v1, v2 and vn, then you may end up with this thing. Okay, is it fine, this thing? What I have done
Yes,
is
sir.
taken.
Yes, sir.
Now you can see, now you can I mean you can see here from equation 1, because this vector v is represented in form of v1, I mean so there are this I mean this v in the linear combination of v1 to vn, I mean you have represented. Okay, so if you compare this equation 1 with equation 2, what will you get?
B1 equals to A1.
Okay, I am writing this in this way.
So this is
A2 and an minus equal to bn. Okay, and you can also, I mean, write in this way. I mean a1, because you have to find the value of a1, a2 up to an, right? So you can write a1 plus b2 and an equal to an minus 1 plus bn. Okay, but if you see, I mean this because this b1 is a1, so you can also write a1 equal to b1 and a2 equal to b1 plus b2, and this an equal to b1 plus b2 plus bn. So now I mean assigning these values, I mean the particular values a1, a2, an to be like this b1 and the sum. So basically this sum for ai, this is like summation bi uh, uh, here, so not this way. Okay, I mean you have to choose this the indexing set accordingly. So by assigning these values to this a1 to an, you can say this will span the whole vector space because it's the same span. See, you have
So we
so
will
if
assign
you
value
just put so you can write other way also, na? So then you can say that v also, then v, if you assign those values, then you can say v is in the span of that set, this v1 minus v2 and vn. Okay, in that way you can show. Is the proof is clear?
Yes, sir.
Yes. Okay. Okay. So moving to the next question. So yeah. So can you tell me how we can do? I mean, at least what do you mean by dimension vector space?
the number of elements in the basis set.
Okay. And what is basis? Basis set.
Basis is a
the
maximum.
li set and spanning set.
Basis is a Li set and spanning set.
Yes, sir.
Li set and
Basically, the
spans
subset of
whole
the
V.
vector space that
Is this correct?
spans
Huh?
Spanning set of V.
So
Span of V
spanning
equal
set
to
is basically
Whole
any
V.
set whose span is the whole vector
The
space.
maximum,
है ना?
yes, sir.
Spanning.
the maximum, the maximum
Yeah, one
Li
by
which spans V.
So maximum Li vector which can span whole vector space.
Okay.
Sir, I will give you a set which is Li set and can be can span V. Then the cardinality of the set will be the dimension.
The
Yes,
subset of the vector.
exactly that
basically
was.
is a subset of the vector space
Yeah.
that spans
I was.
V and
And yes. So yeah,
and
you have to. Sorry, say it again. Your voice was not clear.
Li subset of the vector space, which is span whole vector space, is called the basis of the vector space.
Okay,
Sir,
that is fine. And the yes.
Sir, the dimension Mn is only true for real numbers if field belongs to real number. If it is complex, then it will be 2Mn. Twice of Mn.
It will be
Twice of Mn.
okay. Will be
No,
twice
no,
of
but
Mn.
तब इंट्री भी कॉम्प्लेक्स से आएंगी और ओवर भी कॉम्प्लेक्स करेंगे तो mn ही रहेगा, तो mn नहीं होगा.
अगर C लेंगे ना तो C लेने से
अगर हम
वेक्टर स्पेस भी नहीं होगा अगर M की एंट्रीज.
So okay, whatever you are saying, just answer me. What is the dimension of? So first of all, tell me, is this a vector space?
यस सर, वेक्टर स्पेस है ओवर द फील्ड R. अगर M की एंट्रीज भी कॉम्प्लेक्स है तो फिर फील्ड हम C भी ले सकते हैं.
So out of which, I mean, among three, which are the following forms of vector space? First, you just tell me. So is this the C over C forms of vector space?
Yes, sir.
Yes, sir.
P
Yes,
over R
sir.
also a vector space, but Q over R is not a vector space.
No. So just a minute. This is not Q. This is not Q. Just this is R. Okay, we are not telling. So this is R. Sorry about the confusion. So C over C is a vector space. C over R is a vector space or not?
Yes, sir. Is a vector space.
Yes, sir. Yes.
The vector space and okay. R over R is a vector space. That is.
Yes, sir.
Yes, sir.
Yes,
I
sir.
think clear now. Now, what is the dimension of this vector space? I mean, if I let's say represented by V1, this is by V2, this is by V3. So dimension of V1.
Dimension of V1 equal to 1.
Mn.
Dimension of
No,
V2
so
equals.
nothing related to this M or N. This is first of all I
1,
was asking
2,
this for
and
this
1.
example.
1, 2,
This
1,
is
2,
1.
1.
1, 2.
And what about this V2? Dimension of V2, where V2 is
2,
C
sir.
over R.
Yes, sir. 2.
2.
So can you just write the basis? So this is like this is basis.
Yes, sir. Yes,
You
sir.
can
Yes, sir. Yes.
don't represent. Okay, here you can write this can be the basis. And what is the dimension? So this is
1.
this is
1
also
M
one.
basis. Yes, sir.
This is also that is also this can be the basis, right? So what is the confusion here? So if you just take all the elements, so collection. So this V is a collection of all the matrices of size m by n over field F. Okay. So if you take like all the real entries, all the matrices, okay, and field is also real, then you have to show that dimension is Mn. Okay, and all the complex matrices over the field C, then you have to show that dimension is Mn. So there is no, I mean, like collection of all the complex matrices over real field, there is no such thing, right? So because you have to write now, this is Aij. So where Aij is if let's say A is a matrix of let's say m by n, and this is ijth entry, then ijth entry will coming from the field F. Okay. where F can be R or C. So there are only two cases. Okay, so it is not like it is not. I mean, we have chosen the complex entries, but it is over the real field. Okay, that is not here the case. Now you tell me. So earlier one person is just, I mean, telling the correct answer. Now can you, anyone can tell me how we can show that at least the dimension is Mn?
Total number of entries m into n. So at most dimension is m into n.
But you have to, I mean, give some argument. Total, how you are, I mean, how you can say total number of entries fine. That is, I mean, that is m into n.
Yes sir.
हाँ.
सर जो मैट्रिक्स होती है उसके A11 टाइप के जो भी एलिमेंट होंगे उसे हम एक 100 बाकी जितने भी एंट्रीज होंगी उनसे उनसे जनरेट कर लेंगे और जो 812 वाले प्लेस होंगे उन्हें जनरेट करने के लिए 010 बाकी सारी एंट्रीज 0. इसी तरह अगर हम करते हैं AMN एंट्रीज को भी 1 रखेंगे बाकी एंट्रीज को 0. तो एट मोस्ट जो एलिमेंट आएंगे हमारे पास m into n आएंगे.
So basically you have to take this kind of matrices. I mean,
yes sir.
0 1. So basically 1 at some place and 0 at everywhere. Okay. So basically if you construct all such, consider all such matrices. Okay, how many? So what is the cardinality of this S?
M into n.
M into n, correct. Now, okay, but I mean here in order to say that this is the dimension, dimension is Mn, then you have to show that this S is basically Li set.
Yes sir.
It is Li set. That you have to show. I mean, although we can easily see, but you have to first give me such a set. You have to give such a set, and this is Li, and it is also the spans this vector space V.
तो कोई जनरल मैट्रिक्स लेकर के उसे इससे जनरेट करा कर दिखा दें.
So if you like, let's say we have chosen, for example, if you order to show, if we see this particular example, then you can say this is the element of V here, that is basically m 2 by 2 over, let's say, real. Okay, you can, I mean, change these particular argument. I am just showing, I mean, how you can have an idea of this. So you can write this in this way. Okay. Plus, in this way you can say this will span the whole vector space. Okay. I mean, you have to take this m by n matrix, and then you can say this S spans the vector space V. So in that way you can say, okay, this forms a basis, and the number of elements in the basis is the dimension. Okay, any other idea? So that is one way. In that way you can show that this has a dimension Mn. Any other good way? So is this clear? I mean, this idea?
Yes sir.
Yes. Okay. Okay, so let's move to the question number 3. So here let V be a vector space, and we have to show V is infinite dimensional if and only if there is a sequence of vectors V1, V2, and so on, such that this set, I mean this set V1 to Vn, or we can say every finite set, is linearly independent. That you have to show. Okay, is the question clear to all?
Yes sir.
and
sir.
then you have to show this statement like if and only if. Okay. So yeah. So first you tell me how you are
सर
trying.
इसको इंडेक्सर मेथड से किया है, पता नहीं सही है नहीं, पर इंडेक्सर मेथड से किया है मैंने इसको,
Okay. I mean
क्योंकि
yes. Because you have. Mhm, mhm. So
v
that is fine. You have done by induction method, but how you have done? Just some outline.
We have to consider the cases here. First, we let B is infinite dimensional set. Hello?
Cases.
Yes.
Uh-huh.
First, we
I
assume
mean,
that
what?
V is infinite dimensional set. Then we prove B1, V2, B dash Bn till for every integer n is linearly independent.
V is in infinite dimension. Okay.
This is
Then
assumption, and then we prove that B1, B2, Bn for every positive integer n is Li.
okay.
Since V is infinite dimensional, then it will have it, its
सर v
basis
को
set
तो
will
पहले
have
से
infinite elements.
सर v को तो पहले से
Just
इनफाइनाइट
complete.
डायमेंशनल किया गया।
It is in this question we have given if and only if. So from both the sides we have to prove.
No, no. So yes, yes. You have to show both the sides. So he is assuming V is infinite dimensional first, and he is showing this. There is a sequence of vectors V1 to V1, V2, and so on, such that this every finite set of the sequence is linearly independent. That is we want to show. Now, yes, please continue.
Let
Let him
let
finish, and then.
then since V is infinite dimensional, so basis of V will have infinite elements by the
Then
property basis.
that is fine. Now, what is your argument further?
So
V1 to
from
Vn
this
is
side,
Li. Then
from this side it is proven from the property of basis that it have infinite set of bases. The basis set have infinite
infinite
elements.
set
That
of
is, in basis set
that's
will
two
have
different
infinite
things.
element
Uh-huh.
v1,
That is
v2.
fine. Then
Okay.
how you are
From
using that?
so, theorem होती है ना कि every vector space will have a basis. Since it is an infinite dimension, then its basis will also be have infinite elements.
That is fine. That is given, na?
This
That
is how
I mean,
this is how I
basis.
am writing from one side.
आगे
See, so okay. So let's.
now
I
we
mean,
can
first let me.
and a set
Hello?
So
there is an infinite element basis, then now we can construct and set. Yes, sir.
So just a minute, huh? So let's show if V1 to Vn is Li, that is fine. Now, if V is infinite dimensional, so you can say that there exists, let's say, other vector Vn plus 1. Okay, Vn plus 1,
yes, there
which is not
exists
in.
vn plus 1. Yes.
There exists other vector Vn plus 1
It
such
does not
that
belongs to. Let's say that set is V, capital B.
okay,
Assume.
that is good. So there exists Vn plus 1, which is which is not in
So
V,
that
and
does not exist in V. Hence,
okay. So just a minute, right?
Can we just say that directly that the basis of V can be the sequence of vectors that we are searching?
This is correct, ना? Infinite dimension. तो अब क्या होगा? जब span of B is not V, so there exists other vector Vn plus 1. Okay, such that this set.
it does not
I mean,
belongs to B.
Okay, such that this V union Vn plus 1. This is also Li.
Yes, this is also Li.
Okay, that is the argument you have to give. And the span of V is not V. Here you have used the hypothesis V is infinite dimensional. Okay.
And then assuming this as a B dash and or the B1 set, this also
Okay, so
doesn't
assume
define.
that.
This
So
is
here
B1.
you can say if this is B, let's say
B1.
B1,
B1.
then okay, this is so you define other set B2, that is B1 union Vn plus 1. Okay, and repeat the argument. Again, you can say span of B2,
B2
not V.
doesn't,
Okay.
not V.
Why it is not V? Again the same, because of the hypothesis.
Hence, we have a sequence of vectors Vn linear independent for every positive integer n.
V is infinite dimension. Okay, so we have, like, let's say we have here we have Vn plus 1, and again we have Vn plus 2, okay, and so on. So we can get a sequence of vectors, that is, if this V1 to Vn, I mean, so we get sequence of vectors, okay? Vn plus 1, Vn plus 2, and so on. V1 to Vn, that is, I mean, we have started with such that
Linearly independent.
this set V1 to Vn, say Vn, where n varies from n plus 1. Okay, this is Li. Okay, this set is Li. That's what you have to show.
Yes, sir.
So in this way, you can show that. What is the other way?
This is from one side. Now we have to prove from back side that assuming that this sequences exist, then V is infinite dimensional.
V is infinite dimensional. Then how you can claim that?
So for this, we have considered that V1, let's consider set B equals to V1, B2, that dash Bn is Li. Then we can write a span of V equals to. Span will not be going equals to B because B is infinite dimensional. Span of B is subset of B because there exists Bn plus 1 another element in set B which is also from Li vectors. Are you getting what I'm telling?
No, so I am getting. I am just waiting for you to complete it. Yeah.
So, firstly, we assume B vector like having n elements. Then span of V is subset of B only because here is there is another Li vector which is B1 from V1 to Bn plus 1 this way.
Okay, I mean, so you just try with this also. You can suppose V is finite dimension, because you have to show what you have to show. V is infinite dimension. Okay.
Yes, sir.
That's what you
Contradiction.
have to show.
Yes.
So you assume that V is finite dimension, and with the hypothesis that you have a sequence of vectors V1 to this, you have a sequence of vector V1 to V1, V2, and so on, such that every finite set is linearly independent. So you just, I mean, do it. I mean, how you can arrive at a contradiction, that you have to show it conversely. Okay, one way, and that is not very difficult. You just think about it.
Yes, we can.
You can. For question number 4, how you can do this? First of all, is it clear that this V is a vector space?
Yes, sir. It is a vector space.
It is a vector space. Now, how you can you show that this the dimension of this vector space is infinite? So the hint is, can you use above question as a result here? Can you apply that? This is the hint. You can apply, and how you can apply, you just tell me.
So please tell me this is how is a vector space.
So
Yeah,
how it
zeros.
is vector?
Please give a line.
So basically you have to, I mean, first, so for a vector space you just need I mean this addition and multiplication. So let's say if so you have to define this, what is the addition here. So this is like if f and g are functions, so you can define this as fx and gx, okay,
Yes,
where this
yes, I
x
get.
is coming from this, okay, this, and c times of f you can define here by c times of fx, where x is in this close interval 0 to 1, okay, and where this fx and gx are real valued basically function. So with respect to this addition and multiplication, you can say this forms a vector space. So it is exercise, you just verify with this given addition and multiplication. Okay. Now what I was just asking is that how you can use the above question.
So take sequence x raised to n.
Sorry, say it again. I thought.
Sir, x square, x cube, so on.
I mean, is the set? I mean, whatever is this is the set you are saying. This is the sequence.
Yes, sir. Yes, sir.
But what about the constant function? Because constant function are also, I mean, constant function are also continuous, no? Constant function. Can
Yes, sir.
you generate a
One
constant?
comma
So you
x
have to
comma
include
x
one also.
square.
1 comma x.
One.
So you have to. So this is a sequence by which you can claim that above vector space has an infinite dimension. Because if you take any finite set, I mean, let's say we x 1x square, or let's say 1x, or let's say 1x x square or x cube, then you can say it is linearly independent, okay, and you know how to show that a set is linearly independent, okay, you know na, you just take a linear combination of those sets. If you, let's say, uh, if you want to show that this set is linearly independent, okay, this is a set, suppose S is the set, then if you want to say that this S is linearly independent, then you just have to take this linear combination 1 to n, and this implies this is equal to 0 for
All
every I.
alpha equals to 0.
All alpha I is equal to 0. You can check here, if you take this set or this set or this set, these all are linearly independent, and you have a sequence, basically. So I mean question, you can say we can use this result, but you have to show that is size here. I will ask in the next tutorial whenever we need. Okay. So in this way you can say this is infinite dimensional, but there is also other way. In that way you can say, okay, I mean there is other perspective to say that this V has an infinite dimension, and what is that? If you consider this W as a subspace generated by this vector, I mean, okay, I mean where? So basically W is a subspace generated by this I mean this vector 1x square, because the here vectors are basically functions. So in this vector space vectors are functions. Okay. So if we consider W is a subspace, so you can say if W is a set which is generated by this set 1x square, okay, then you can claim that W is a subspace of V. Okay, and so it is basically all the polynomials set. I mean, it is basically set of all polynomials. Okay, and this set of all polynomials forms a subspace of set of all continuous functions, because all polynomials are continuous, and it has, and basically this set forms the basis for the subspace, this subspace set of all polynomials, okay, and this basis has an infinite element. So the dimension of a subspace is infinite. I mean the dimension of W is basically infinite, and W is a subspace of V. So what does it imply? Dimension of V is also infinite. I mean, this is another approach in that. I mean, you can use the above question also, and you can use this argument too. Okay. So I mean, time is roughly over, but yeah. So let's just see how you can do the question 5. Just tell me the idea how you have done that. So is the question 5 is clear? I mean, what do you understand with this? Yeah, so that's what I was talking about. This PM, so here the W, the type of W which I just explained is here, this PM. So here the PM over R is the vector space containing all the polynomials of degree less than M. And over here W is the collection of all the polynomials basically. The degree is not specified. But yeah. So basically PMR is a vector space containing all the polynomials of degree less than or equal to M. So, and this P0, P1 to PM are the are the vectors in this PMR such that this Pj2, if we put in place of this variable x, and if we put 2, then it comes out to be 0. So this property is satisfied. Then you have to show this is not linearly independent. Any idea?
तो पी नॉट कांस्टेंट होगा तो वो जीरो हो जाएगा, तो जीरो कंटेन करेगा तो वो एल टी.
No. So whatever just you saying, that is fine. That are basically the intuition, but you have to write it, no? That you have to write it, the concrete argument. Then how will you write? I mean, you have to start with what are the things that are given to you, and what are the things that you have to show. I mean, arrive at some conclusion. I know what you are saying. I mean, that is basically a correct idea. But how you will start? That is the thing. So tell me how will you start?
कोई जनरल पोलिनोमियल ले लेंगे सबसे पहले, दैट PM विद द एलिमेंट ऑफ द वेक्टर स्पेस PM ओवर R.
सर पी नॉट यहाँ पर जीरो है ना सर.
पी इसमें से कांस्टेंट जो जीरो आएगा उसे वापस पोलिनोमियल में रखेंगे फिर. और जो ये हमारा सेट है इसमें कुछ पोलिनोमियल ऐसे होंगे जो सेम एलिमेंट्स को जनरेट कर रहे होंगे और एक दूसरे के मल्टीपल हो जाएंगे, जिससे लीनियरली इंडिपेंडेंट रहेगा, डिपेंडेंट हो जाएगा वो.
लीनियर डिपेंडेंट हो जाएंगे, ठीक है. I mean,
जैसे
so
P1 में
because we are
x माइनस 2 अगर ले लें तो वो, और साथ में 2x माइनस 4 भी ले लें तो वो दोनों एक दूसरे के मल्टीपल हैं और P1 ऑफ 2 इक्वल 0 भी दे रहे हैं. तो वो लीनियरली डिपेंडेंट हो
सर
जाएगा.
यहाँ पर पी नॉट जीरो है इसलिए सर.
yeah there are multiple
वेक्टर
answers.
कंटेन करेगा तो
There are multiple answers. So say it one by one. So one student is giving an example. Okay, let's go. क्या बोल रहे हो?
सर P0 कांस्टेंट पॉलिनोमियल है और हमें पता है कि P2 इज 0, तो कांस्टेंट पॉलिनोमियल 0 हो जाएगा, तो ये सेट LD हो जाएगा.
सेट LD हो जाएगा.
यस सर.
जीरो कंटेन.
बट
ये सर जो P नोट है सिर्फ वो कांस्टेंट को ही रखते हैं ना, वो कांस्टेंट पहले से 0 हो जाएगा. तो 0 वेक्टर कभी बेसिस जो लीनियर LI सेट होता है वो कभी 0 वेक्टर को कंटेन नहीं करता.
यस सर.
क्या दोबारा बोलो क्या बोला तुमने?
P0 is
सर
0.
जब हम P2 को 0 रखेंगे तो हमारे पास जो A नोट
ये बताओ
होगा,
कि P0 को क्या
P नोट
कांस्टेंट है ना सर.
P नोट 2 इक्वल टू 0 होने से A नोट. Yes,
ठीक है. So there are multiple answers. So let me first tell me what is my solution. ठीक है. So see, I am saying this forms the basis. Is it correct?
Yes, sir.
Yes, sir.
And why it is correct?
It spans
Because basis is
it
a
is elastic.
maximal basis. Basis is maximal. So there is a difference. First, I will explain it later. What is the difference between maximum and maximal? You can also explore it, but basis is a maximal Li set. Okay, Li subset of vector space V. So, and what is the cardinality here? The given set. What is the cardinality?
M
Cardinality
+1.
of V is m+1.
M plus
Okay, this is so. It is a Li set and it is maximal, so it forms the basis. Okay, that first thing you should be clear with. Now if you let's say if you want to write, so it is a basis. Okay, that means span of V will give you this vector space. Okay, so if you just assign this P naught, so what I have just taken, if you have taken this, now you have to choose this P naught to PM. What are your P naught to PM? Okay, so P naught to PM are such that if you put 2 in place of X, then it will give you 2. So that means if you want to represent this, let's say constant polynomial, let's say 1, in terms of P naught to PM. Now, if you put, let's say, so these are functions. Okay, these are functions, and you can represent. Okay, and if you put x equal to 2, then what would it be? This is equal to 0. You put x equal to 2 here,
Yes, sir.
but this is not the possible, no? This is not possible. So
Yes,
this
sir.
is
Contradiction.
not possible. Oh, yeah. So if it is not clear, so some of you are saying some other ideas also, but let me know. We are running out of time, but that is basically an idea. So we will, explain it later on also. But that is what exactly I want to say, that we cannot represent 1 in this form, 2 PM. Okay, so yeah. So question 6. Okay, we are left with 9 questions. Okay, then we can close this session and we can meet in the next class.
yes.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.